With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question. Now what the question says, which one of the following metals cannot be obtained on electrolysis of the aqueous solution of its salts? Now we are given four options. Now firstly we know that in electrolysis metal is obtained at cathode. Metal is obtained at cathode. Metal is deposited on this cathode, and we know that at cathode reduction reaction takes place. Now we have to write the value for the standard reduction potential for the following options to compare the deposition, whether they will be deposited on cathode or not. Now we know that we are given the aqueous solution of its salt. Now in aqueous solution we know that the one reaction that will take place is H positive plus electron. It will give rise to half H2. And we know that standard reduction potential for H positive to H2 is taken as 0 volt. Now the one with higher value of standard reduction potential than that of H positive to H2 will be obtained on the electrolysis of aqueous solution. Now we know that at cathode reduction takes place, so the metal should have, or metal should be, a good oxidizing agent, because a good oxidizing agent reduces itself and oxidizes other. Now we will write the reaction that can take place. Firstly, Mg2 positive plus 2 electron will form Mg on cathode, and if we see the value for the standard reduction potential of Mg2 positive to Mg, the value is minus 2.36 volt. This is the value for conversion of Mg2 positive to Mg. Now we will write Ag positive. We know that Ag is in +1 oxidation state, plus electron will give rise to Ag, and the value for this reaction E0 is Ag positive to Ag is 0.80 volt. Now we are given Cu, so Cu2 positive plus 2 electrons when give rise to Cu, the E0 value Cu2 positive to Cu is 0.34 volt. And at last we are given chromium. Chromium is in +3 oxidation state, Cr3 positive plus 3 electrons will give rise to chromium, and the reduction potential for chromium 3 positive to chromium is minus 0.74 volt. Now these are the values for the standard reduction potential. Now this minus sign indicates that it is not favoring the conversion of Mg2 positive to Mg. Rather, the reaction is taking place in the backward direction, that is Mg is in tendency to form Mg2 positive. So this is the bad oxidizing agent because it has no tendency for the reducing part, so this will be not possible. Now we are given Ag positive. The standard reduction potential for Ag positive to Ag is 0.80 volt. Now this is positive, it means it has a tendency to reduce itself, and so it will act as a good oxidizing agent, so it can be obtained by this electrolysis. Now also we are given that copper 2 positive plus 2 electron give rise to copper, and the value for the standard reduction potential of copper 2 positive to copper is 0.34 volt. This is positive. This also indicates that it is favoring the reduction process, so this is also possible in the electrolysis. Also at last we are given chromium 3 positive plus 3 electron give rise to chromium, and we have the standard reduction potential of chromium 3 positive to chromium, that is minus 0.74 volt. Now this minus sign indicates that it does not have a tendency for the reduction part, rather it have a tendency for the oxidation part, so this cannot be possible. Now there are two possible cases, that is Ag positive and Cu2 positive. The reduction potential for Ag positive is greater, so Ag positive will form in a good extent. Now we will check the options. We were asked which of the following metals cannot be obtained. Now we can see that Mg cannot be obtained because it has a oxidizing potential, and chromium cannot be obtained. So these will be the answer. Thank you so much.
for class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.